In case you don't remember scientific notation from your science class, here's the definition. It is a number expressed in the form a times 10 to the nth power, where n is an integer and a is between 1 and 10, where it can be 1, but it can't be 10. And what scientific notation is used for is super huge and super tiny numbers where you want the place value of the numbers to be separated from the numbers you multiply, like the significant digits. Um, and it's exclusively used in science because that's where you get the super huge and super tiny numbers. Like the mass of a star is super huge, but the mass of an electron is super tiny, right? Um, so 32,000 in scientific notation is 3.2 times 10 to the fourth power. This 10 to the fourth power tells you the place value of the 3. Okay, because 10 to the fourth is 10,000, so you have 3.2 10,000s, which is 32,000. That's how scientific notation works. Now, on your calculator, if you get something in scientific notation, it doesn't have the times 10 to the, it is a 3.2 with a little bitty e and then the exponent of 4. And some of you might have seen this in one of the PSJs, like you raised 2 to the 20th power, or you found like 20 factorial or something, and it gave you some weird e number. Well, it gives you that number it gave you that number in scientific notation. If you have a really tiny number, meaning a number really close to 0, you can also write that in scientific notation. And the only difference is that you have a negative exponent, in this case negative 5, and this 10 to the negative 5 once again is the place value of that 5, okay? And 10 to the negative 5th power is 10, 100,000, 10,000, 100,000. So that 10 to the negative 5 is 100,000 with the TH, S, and so that's where the 5 is. Now, in order to convert numbers to and from scientific notation, you don't have to, figure out the place value. It's really easy. If it weren't easy, then no one would use it. If it were some really complicated process, then why do it, right? So the way to convert numbers to scientific notation is to locate the decimal and then move the decimal so that the number is between 1 and 10. So you have to move it here in between the 3 and the 2, and then what you do is you count how many places you moved it. So you moved it 1, 2, 3, 4 places, and the number of places tells you that exponent. And so I do the exact same thing here when the number is really close to 0. I move the decimal so that my number comes between 1 and 10, which in this case is 5.7, and I think about how many places I moved it, and I moved it 5 places. Now, since I moved these 4 to the left, that means I'm going to get, I'm adding to the exponent, and since I moved it to the right here, that means I'm going to get subtracting from the exponent. You convert these into scientific notation. So we're going to have a quick check here. Now let's see if you got those correct. I'm going to move my decimal so that I have a number between 1 and 10, so that's 4.56, and I have to count how many places I move the decimal, 3, 6, 7, so that's times 10 to the 7th power. And in this case, I need to move my decimal, so I get a number between 1 and 10, so it's 9.87, and I have to count how many spaces I moved, 1, 2, 3, 4, 5, 6, 7, 8. So I had to move it 8 spaces. So for those two, you should have gotten 4.56 times 10 to the 7th and 9.87 times 10 to the negative 8. Now let's convert from scientific notation to standard notation, meaning the normal way numbers look. So if I have 1.64 times 10 to the 10th power, then I'm going to write 1.64, and I need to move the decimal 10 spaces in this direction because a positive 10 power means a big number. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I need to do in these empty spaces is add my 0 placeholders. And then if I have something to a negative exponent, I do the same thing, but I know negative exponents mean numbers that are closer to 0 and not super huge, but super tiny. So I have to move my decimal in the opposite direction. In this case, 3 spaces, and so I have to put in 2 placeholder zeros, and so I get this value right there.